finding maximums and minimums on your calculator. Okay, so here we have a function that I just made up, x cubed plus 2x squared. Okay, this is the example that we did in class, but I'm going to review not only how to find the maximums and minimums of a function, but also how to use zoom box so that we get a better picture. So enter this equation into your calculator right now, x cubed plus 2x squared. Okay, and let's hit graph, and we get this picture here. But the maximum and the minimum are kind of small, so let's maybe get closer up on our maximum and minimum. And remember, to do that, you go to zoom box, which is zoom 1. So we hit enter. Okay, and you see the little spider right there. I'm going to move the spider up to the top, what I want to be the top left corner of my new image, my new calculator screen. Okay, so I'm going to hit enter to fix that corner there, and then I'm going to drag the spider down to the lower left-hand corner of what I want to be on my screen. And then I'm going to cursor to the right. You see the box opens up, and I'm going to keep cursoring until I get the picture that I want to appear there. See, now I have the bumps. I'm going to get those really close up. So I'm going to hit enter. And now my maximum and my minimum are really close up. I'm going to drag that onto here because I can. There it is. Okay. So my local maximum is this point here, and my local minimum is this point here. So now I'm going to refresh your memory on how you find the maximum first. Okay. So this is our favorite button when it comes to having our calculator do work for us. So we really want calc. It's in blue. So we go to the second button and we go to calc, or trace, which is really calc. And we're looking for a maximum. So I'm going to cursor down to maximum. I'm going to hit enter. And it says left bound. What it wants to know is it wants me to grab a point somewhere to the left of the bump, of the top of the bump. Because it wants to know which bump I want to find. There could be several bumps on the calculator, and it wants to know which one. So I'm going to cursor to the left. I'm going to move the spider to the left of the bump, and I'm going to grab it. I'm going to hit enter. Okay, and then it says, what's your right bound? So now I'm going to move the spider to the right side of the bump. I'm going to make sure I don't go so far that I'm over here, because then it's going to get confused about which bump I'm talking about. So I'm going to hit enter, and then I'm going to move to the middle because it's asking me to guess. Okay, and I'm going to hit enter there, and there's my answer. It says that my maximum coordinate is negative 1.33 and 1.185. Okay, so this is the value where the maximum occurs, where the max occurs. And this is the maximum value. Okay, remember the y is the output, so that's your actual maximum value. Let's say that my equation, this equation here, was like a volume equation or something. This right here would be the maximum volume, and this would be whatever my variable was in there. Like, let's say it's a radius, or it's the base or the side of a square or something. It says this is the thing that's going to maximize that. Okay, so finding a minimum is going to be the same process, but we're going to look for a minimum. So we're going to go to second calc, And instead, we're going to go to minimum. It's going to ask us the same series of questions. Left bound. So this time we want to be right there. We want to move the spider to the left of it. Hit enter. And move the spider to the right of it. Hit enter. And then it says yes. Okay. And there's the minimum of this function. All right. So same deal. This is the x value where the minimum occurs, and this is the actual lowest local minimum for the function. Remember that this suggests that the actual minimum value heads towards negative infinity, and the actual maximum value heads towards positive infinity. These are local or relative extrema. Those are the ones we're looking for.